In this second video, we're going to be greeted by some area, perimeter type problems, and also going the opposite direction where you'll have the equation and then you'll have to use words to describe it. So with these writing formulas problem, let's make sure you're clear on what a formula is. Well, a formula might be something like area, where I have length and width. And if I know the length and the width of a shape, a rectangle, I can just plug them in and go from there. So I'm going to assume that background knowledge is there and that you're clear with what a perimeter is. And I'm going to move into this first one. The perimeter of a rectangle equals 2 times the length plus 2 times the width. So let's draw a shape. And what they're saying is that the perimeter is dependent on length and width. So that's the entire distance around the shape, not the shaded in area, which would be the area. So let's label this. Well, we know that there's usually length. We know that there's usually width. And so we're told that the perimeter of a rectangle, which I will write with the letter P in caps, so that's a capital P, is equal to, because I'm seeing the word equals, 2 times the length. Well, whenever I have 2 times something here, I could use a times symbol, but since it's going to be next to a variable, I don't need to bother, plus 2 times the width. And yeah, you don't really write an L like that when you're dealing with algebra. It's most common to write a cursive looking L so that it's clear from being a 1 or something else. No need to box this. I think it just makes it more complicated if you do, but we've totally taken care of that first request there. So in a right triangle, draw a right triangle, and as you may or may not remember, right triangles have 90-degree angles, and that's what that's all about, and we indicate that with a little box in that corner that communicates that it's clearly a 90-degree angle. The square of the measure of the hypotenuse C. Well, this is a little vocabulary you might be rusty on, but the longest side of a right triangle is the hypotenuse, so let's label that C, is equal to the sum of the squares of the legs, A and B. Well, here are the legs, A and B. In a right triangle, the square of the measure of the hypotenuse, so that means I have to take the hypotenuse, which they've given us as C, square it, is equal to the sum of the squares of the legs. So that means that I'm going to square this leg, I'm going to square this leg, and the reason that it's not written like this, I would call A plus B as a quantity squared, I would call that the sum of the legs squared. So this would be incorrect, while this would be perfect here. And this is the Pythagorean Theorem if you've ever seen it before. So in these first two problems, they're just throwing some geometry type formula problems to us. Translate equations into sentences. So you're told to take each equation and turn it into something with words. I'm going to move this page up and pinch to zoom so that my handwriting is more clear. So, you could get fancy here, so let's use the word product. The product, which communicates times, of 3 and a number, N-U-M-B-E-R, sorry about the handwriting, plus 5 is 14. No need to write the words out there. I also could have said 5 added to the product of 3 and m is 4. I also could have said equals. I'm sorry, I said 4, but I should have said 14. I also could say equals 14. Okay, now I see something plus something else, so I'm going to say the sum of W and V quiet quiet sounds in the neighborhood and somebody starts a car, they think they're cool with a loud engine. So the sum of W and V is Y squared. And for this one, you could have been like, the sum of two different numbers is equal to another different number squared, if you wanted to. But let's not complicate things if we can avoid it. I'm going to make these OYO, and I will write possible answers below. And when I say OYO, I mean on your own. So pause the video, give yourself time to write something here, because in 5 seconds I will just have the answers up for you to compare. 4, 3. Okay, in this first one I have 13 is equal to 2 plus the product of 6 and a number. I kept it general as opposed to saying t. If you put t, that doesn't matter. 1/4 of a number plus 5 is the same as the difference of that number and 7. I also could have included the word same, but by using the word that, I wanted to show you how in the book you might see ones that you have to translate back and forth where they reuse the same variable, and they're going to say different things to tell you if it's the same versus another type of number. Also, one small thing, if you do have 1/4 written as a number, I think I'd rather you write that out as a fraction, just for clarity, and to make sure you're clear with what that's saying. Okay, we get a challenge problem. So it says Tierra is 5 years older than Raphael. The sum of Raphael's age and twice Tierra's age equals 46. How old is Raphael? Now this is a challenge problem, so it's just a chance for us to extend our learning and see what we're able to do with these. I see 2 facts, one fact, and then a second fact. Of these 2, I think the first one is definitely easier to deal with. So let's think about Tierra being 5 years older than Raphael. So your first gut instinct might say, well, that means I can do t plus 5. I'm not saying this is correct, I'm saying this might be your instinct. T plus 5 is r. Now let's think of this. If Tierra is 5 years older than Raphael, well then if Raphael is 5, I'll use a number different from 5 just to not confuse it with this 5, sorry. Okay, let's say he is 10. If Raphael is 10, then Tierra should be 15. So what happens when I try to plug in 15 for Tierra? Well, 15 plus 5 gives me 20, and Raphael is not 20. So that gut instinct was wrong. And let's instead see what happens if I take r plus 5 is equal to t. Now you could do this through subtraction, but I prefer thinking of it like an addition problem, because this reads more like addition to me. So t is 5 years more than Raphael. Okay, that kind of makes sense. The other thing too is let's plug in that 10. If he is 10, 10 plus 5 gives me 15, and that works out okay. So I'm going to clear this ink and rewrite what I know it is over on the left side. Now, as you're doing problems like this in your book and you are feeling like doing some scratch work or something, try and keep that over here, but don't feel like you have to erase it. It's good for you to be able to go back to your thought process and learn from it, but try to avoid keeping it on this left side. Try to keep it to the right, because I like this to be the side work. Like if you ever had to multiply a 2-digit number by another 2-digit number or something and you didn't have your calculator, that's where that should go. And this one's a little bit more challenging. So let's say, well, the sum of Raphael's age and twice Tierra's age equals, okay, I see the word equals. So I'm going to put an equal sign here, and I will break apart the left side from the right side, which makes it easier if I put the number 46 here, and I just stop. So that means that I have to take Raphael's age and add it to twice Tierra's age. So the sum of Raphael's age and twice Tierra's age is equal to 46. Well, how old is he? Now, we have not done equations where you have 2 and had to solve them. So let's see how you do with trial and error. And here's what I mean by trial and error. You take a value like I did with 10, plug it in and see what happens. So if Raphael is 10, then Tiara would have to be 15. But this should also work when I plug it into the other equation. Well, here's 10. Here's 2 times 15, becoming 30, and 10 is 46. Okay, I want you to pause the video and use trial and error to see if you can come it up. But the trial part is I tried something out, and then I realized this did not work. And then maybe you decide, should I increase or decrease their ages to make this work? I wrote 46 down here. That was a mistake. You've probably been confused in thinking about that. I apologize. This should say 40, but keep in mind that was my target. That's why I wrote that down on accident. So make sure you pause this. I'm going to show you what I get after I do trial and error. Okay, so just talking about this, I could have tried something outrageous like 20. Well, if I tried 20 out and 25, I'd probably be jumping way too far. I knew that once I got 40, 46 was pretty close. So if I plugged in 11 for the age, that got me closer, where I would be like, well, 11 plus 2 times 16. Well, I'm getting that because 11 plus 5 is 16. Well, that got me closer, but when I tried Raphael being 12, I would know that Tiara was 5 more than that. Well, 12 plus 5 does equal 17. Of course it's going to work in that equation because that was the easier one I chose to try this out in. But I should also make sure it works in here. I'm drawing an arrow just to separate my work from the equations that I wrote. So here's 2 times 17, which gives me 12, plus 34, which gives me 46, which checks out in this equation. So now I can go ahead and label this. Raphael is 12 years old. I'm more inclined to write this as a sentence, and the reason I'm more likely to write it as a sentence is when I go back and reread the problem, they were specific. They said, well, how old is Raphael? Now you could tell me Tiara as well, and you may as well, by writing it up here if you haven't. But since that's all they asked for and you were to look in the back of the book, you might want to keep an eye out for, if the book says 17 and you wrote 12, that doesn't mean you're wrong if they asked about Tiara. Likewise, if the opposite was true, you would know you were fine. So sometimes you'll have to reread what they asked for to make sure that the question you answered was what they gave you the answer to. This will be the assignment for it, and a little friendly reminder, please write directions for this section. And yes, this was part 2 of 2.1's notes.